Okay, so welcome back. So now what we're going to do is we're going to cover some other vocabulary and some other definitions here. So again, these are related to triangles, so I'm relating all these two triangles. So median, the median of a triangle is a line segment that is drawn from a vertex to the opposite side that is drawn to the midpoint of the opposite side. Okay, so for example, if I draw a triangle and I want to draw to the midpoint of the opposite side, let's say if I want to draw it to there, where these two sides are the same now, these two line segments. Okay, so let's call this, right? So now segment DB is equal to the length of segment CD. Then this line here is called a median. Now in a triangle there are three medians that you can draw. I could draw to the midpoint of this line, right? Where these two line segments are the same. Or I can draw a median from this vertex over to this line where these two line segments are the same. And so in this case, this intersection point of the medians has also a special name called the centroid. It's the centroid of a triangle, okay? So there's that. Okay, now, angle bisector. Okay, what's an angle bisector? Okay, so an angle bisector, by its name, you might guess, is a line segment that bisects an angle. What does it mean to bisect? It means to divide it in half, okay? So if I have a triangle like this, and I want to draw an angle bisector, it would be something like this, where these two angles are the same, okay? And again, just like the median, there are three angle bisectors I can draw, right? Because there are three angles, three vertices. So I can draw one like this. So I can draw one like this that bisects that angle, and I could draw another one like this that bisects this angle. Now again, my picture notwithstanding, all of these are going to be the same. Well, not the same, but these are going to be the same, and these angles are going to be the same. Okay? So now, the three angle bisectors also intersect at a point. Okay? So that's an angle bisector. An altitude. An altitude is a line segment, again, drawn from a vertex that is perpendicular to the opposite side. Okay. So again, take our triangle. And I can draw an altitude from here, right? And it creates a right angle, so it's perpendicular with the opposite side. But I can also draw another one to this side. I can draw a perpendicular angle let me see here. It's not real. My triangle's not the best. Let me do this. Okay, so if I draw, well, now that I'm using a different color, so let me draw my angle bisector down here. So that would be an altitude, right? The altitude tells us the height of the triangle, by the way. So this is the height of the triangle. This is the altitude, okay? Now, I could also draw an altitude from this angle, but it would actually come out to here, because if I extend this line, right, if I extend this side out, then my altitude would come out to this over here. Okay, and again, if I did it over here, then my altitude would come out this way. So the altitude doesn't always stay inside the triangle, okay? But my point is this: in every case, the altitude is going to tell you the height of the triangle. And just like with the median and the bisectors, the angle bisector, they also will intersect at one point. Now, these 3 points, the centroid where the medians intersect, the point where the angle bisectors intersect, and the point where the altitudes intersect are not necessarily the same point. Okay, so don't assume that they're the same point, because usually they're not. Okay. So that's it. That's all I want to say about this. Again, make sure you understand these definitions, because we're going to use them, and it's important going on. So other than that, have a great day, and I'll talk to you guys soon.